Welcome back. You've got the DJ, the Go DJ. I've got DJ voice today because I got a little bit of a whatever. I'm getting over it. And I was driving into work and I was thinking maybe they shouldn't have called this language Go. Maybe they should have called it C4. Because I think C4 has really good associations and connotations. C is much more serious. It's a C programming language, C++, C Sharp. The next iteration of C is C4. Right, it'd be the fourth one, and C4 has all those good, associations of like special forces and explosions and blowing stuff up and getting things done. They should have just called this language C4 because Go sounds like a kid's language.
Could you just imagine trying to look up help documentation on it?
Oh, that'd be awesome. C4 language bridge, and you get like how to blow up bridges. That'd be cool. Well, they'd have to call it C4 lang. Right, like Golang, so you could look it up. But anyhow, yeah, Go. But I could see also Go because of Python, right, and Node. Those kind of have the funner little language deal. So we left off slide 46, lecture 41, and there's we'll see how we get through this stuff. If not, if we get through too much, I didn't get as much prep done as I'd like. But if we get through all the stuff, then there's a couple of places where I'm kind of banging my head against the wall. I wasn't able to solve it, so we could group troubleshoot it. And like one of them is doing ancestor queries. I was trying to get ancestor queries working this morning, and I don't know what the heck was going on. But you guys could point out, hopefully, many minds are better than one, and we could figure it out. So 46, what is it? 46, 41. 46, 41. So getting records, we saw that there's three ways we could do that. We could do it by, hey, just give me the record and here's the key. Or we could say, field query. So we could say, hey, give me everything where the role is manager. Or we could do an ancestor query where it's like, I want to see all the posts from this one user. And so here's getting by a key. And so we got a struct with term and definition, and it's just better, I think, to look at this code in WebStorm instead of the slides. So S303 get 5303 get 5303 5303. I changed the name of it. 01. Wow, am I in the right place? 5302. There we go. 530203 get. All right, close this stuff. So there's my init, handle words. Now I've got a struct, and then handle words, splitting up the URL. Give me like, whatever word is right after, the first one in the URL, so to speak. And so if it's dog or cat, then I bring up that specific word and I show word. So come down and look at show word. And with show word, we get the context and we get a new key. Here's the kind. And the term that I pass in here is going to be that first part. So I define that right here, right there. So there's the term, and then I pass in the term. And so it's going to look it up. When we have a new key, we are creating the key. We're not waiting for App Engine to do it. So it's either going to be based upon some string or based upon some number. So we choose one or the other in the function, and then we create the key gets created. And I'm creating an entity word, which is instance of the word struct. That totally makes sense. And I'm calling it entity. That's list words. And then datastore get. And so here's the get, right? Pass in the key. Give it the entity for it to put in. It needs to be the address, and then once we get it right, so datastore get returns an error, and then where is it that we get it out? Datastore get context key. It's in the entity, and so down here we could get entity, term, and definition. Pretty straightforward, right? Anybody have any questions about that one? And then just to look through the rest of this. So that's show word. Or if it's a post, it's going to be save word. So when we look at what save word does, So request the form value. Since we passed into save word this response and this request, right? We're going to have, so this is what kind of came back from the server, and well, this is the server. So handle words, the client posted this, right? This came to the server, but we're passing these two with all of their data. And so when we have save word down here, we could just say right off request form value, give me the term, and then form value, give me the definition, and then get app engine, new context, the request, get new context, and then build that new key off of the term, right? And then get an entity, and then we're putting into that entity, right? We're taking that entity and we're putting that to the data store. So the put. And then list words is, so we looked at getting something by the key. We just kind of reviewed putting something. And then here's how to get something by a query. And this is a query where we're querying what? What is this right here? How would you describe that? What is that? What's the name for that? That's the kind. So we're getting a query by the kind, and then we're going to order it by the term. So list them all alphabetically like a dictionary. And so when we do that, and this is still novel to me. You brought candy because it's almost Halloween.
I'm going to be passing them around. So you guys want one too?
Do I want those? No, thank you very much. I really appreciate the thoughtfulness, and if it's vitamin C, I'd totally take you up on it. So the query deal is pretty interesting, like just looking at that in the documentation, because seeing what you could do with it. So here's type query. And we were seeing query.order term. Okay, so query. And new query takes a kind. So I'm querying a kind. Gives me a pointer to a query, which means that I now have access to all these methods. And we did order. So there's the order. And this returns a pointer to a query. So if this gives me a pointer to a query, right, I could then just start chaining these things together. So that's kind of neat, right? So order, I could order things, or I could filter string, value interface query, or I could, what was the other one? Ancestor right here. See, I even have it highlighted from when I was working on this morning still. Thank you very much, Lori, for the candy.
No problem.
Very kind of you. Eunice, do you want candy?
I usually give them to the Save Mart guy, but at my grocery store, but he gets too much. You want some, John? Sure. Want candy?
He'll stop for candy. We'll stop for candy. So we could do an ancestor query, same way, right? So just the query thing, that's pretty much how it works. And then qrun, right? I'm wondering if run is in there. So run right here gives us a pointer to an iterator. And I haven't looked at run yet, but that's like one of my questions. Run runs the query in the given context. All right, so that's interesting, right? So we do run right here. Right, we could even chain that to the end and then just had it all run, maybe. Would we have needed Q again? That's the only place we use Q's right there. And then we do a for loop, and as we for loop over everything, I'm not sure what we're for looping over here, iterator next. So iterator's got a next function. So let's find that. Like, I'm not seeing it. Iterator gives me an iterator, runs a given query. So one thing I might do is like right here, iterator. Just go to that, right? Like qrun gives me an iterator. Qrun gives me an iterator, and then here's my iterator. And I'm holding down command in WebStorm if you just happen to be watching this and you're like, how is he doing that? And then I'm looking to see if iterator has run. Q, brief,
Those are all private data, so you don't have to worry about that.
iterator next, iterator cursor,
There it is.
Cursor string.
wait.
Oh, did we pass it? There's the Q
Oh,
run.
no, it was an error run. Never mind.
Cursor. So I could do this right here.
Well, the next one up, but yeah.
What are you looking for?
I'm just looking for the run because I didn't see that.
Run is returning the iterator.
Run returns an iterator.
Oh, what am I looking for? I was looking for. I was looking for next. So that's it right there. Okay, cool. Iterator next. And is that in the documentation? Because I don't like for iterator here. Ah, there we go. Type iterator. So there we have cursor and we have next. Cool. And next gives the pointer to a key and an error. So pointer to a key and error, and then if data store done. So done is in here somewhere. That's kind of interesting. Data store done. Like, where did that come from?
It's an ordinary error just designed to be the specific error returned. It's
variable.
not an error. Yeah, it's
It's
not
right
an
there.
error case. It's kind of more of just an unusual case,
So it's like end of file but for your iterator?
pretty much.
But-
It's the equivalent.
Done is returned when a query iteration is completed. So that's that right there. And it's a variable. So that's kind of like a thing to remember for me is always look at the variables inside of the documentation to see also. And then we have done. If done, then we break out of it. Otherwise, entity term, entity definition. So it's kind of interesting to me that we just do an infinite loop. An iterator next every time is calling, right, the next one, next one, next one. But is iterator next in and of itself, is next in and of itself a loop? Will we use it that way? I don't think so, right? I mean, that's the way we use it. It's the way it's laid out.
Yeah.
Next returns the key of the next result. When there is no such result, done returns the error. If the query is not keys only. So it's kind of like, what's that thing you told me with seek to reset it, right? Like it's like almost a seek head. I'm at this record, this record, this record or something.
Yeah.
Is that right? All right. Anyhow, just interesting to think through.
Yeah, you could probably arrange it so that the next call is in the for loops header line, but it would be a bit tricky with your variable setups. It's almost clearer to do it this way.
Yeah, I like that. I guess just like the way I'm used to seeing it, like Cold Fusion days, was like you would just loop over your query results. Like that was the way you'd call the query. But
If you wanted to do it that way, with your query, you can do a get all, and it'll return a slice of keys, I think, and then you can do a for range over the keys.
oh yeah, that's cool. So get all.
Yeah, you can use the query get all. Although if you're going to do that, that'll give.
Show them the size.
Slice of keys and then use the keys.
Well, I don't think it's needed. There's also a destination there. Give you the values.
Oh right. But then that probably puts us in the same thing, right? We got to get the next one, next one, next one.
You can use a range-based for loop over that destination, which will be a slice, according to that further docs. So this destination must have a type of pointer to slice or pointer to slice to pointer stuff.
What's the P part? No, non-pointer type.
P implements
Okay.
property saver loader. Or load saver.
Okay. Oh, property load saver. So that could be a struct.
So yeah, you can use get all, but if you're using get all, use a limit. You don't want to use get all and get the results back with 20,000 results. If you've got a big data store.
So that's the two that we were looking at.
On the slides.
Thanks. The two that we're looking at were key and doing query. We didn't do the field query here. We did order, right? But we did a query, and so kind of interesting. So we saw that right there, and then this is the one we just looked at, doing a kind query. And then we already saw pudding. And we saw this stuff, everything being written in. And then the next one down is filtering it. So that's what filtering would look like. That should be pretty straightforward. Anybody have any questions about that? You can see that more straightforward.
Note those are all strings.
All strings. And if we look at the documentation, compare that to the documentation. Filter right here. Filter string and a value interface. So filter returns a derivative query with a field-based filter. The filter string argument must be a field name followed by an optional space followed by an operator. Fields are compared against the provided value using the operator. Multiple filters are ANDed together. So here we go. Wrong one. Well, no, it's not in there. Right there.
So that filter is going everything from that starts with C all the way to starting with the D.
Yeah.
It's not quite hit E or beyond.
Yeah. All right, so there's what we get if you filter it. C to D, but no E or beyond. And that's seeing it there. And then docs, we've been looking at that. Oh, there's done. Look at that, dude. I totally already had it in the slides. I sometimes am amazed at myself how I learn things like many times over before I know them. I'm like, oh, I already looked that up.
So note that when you're doing queries, any kind of queries, order, just plain order, filter, whatever, it's got to add indexes for that query onto the data store to make it faster to look stuff up for that, and that will use up your space and your rights to your data store quota quite fast if you're doing it carelessly. So try to limit the number of queries you do, because that will, I think for every extra field that it has to index, it has to add an extra like 2 rights in addition to every right that you would do.
I thought every field was automatically indexed, no?
No, it will when you're running it locally, it will determine which queries you're running and create a file that tells the overall app engine which fields need to be indexed.
Yeah, it's like another YAML or something, right?
Yeah, it'll generate an index.yaml.
Mm.
So for our example, it will be indexing the term field. It'll be indexing the term field in the alphabetical order.
Mm.
And so because of that, every time you have to write anything of that kind, word kind, it has to write 3 times, once for the thing itself, and then twice more for adding to the index. And you only have so many rights on your free quota. So
Here's an exercise. You could either create your own, like I said on Tuesday, or you could create a user profile page that requires login and saves the profile information in the data store. So we did this with sessions, and then we did this with Memcache, and then you could do this with data store, right? So save profile information in the data store. You know, variations on it. And so here's the solution. Give you homework, and then I'll give you the answer. So I used Julian Schmidt's router, and you can kind of see the difference here. I'm get and post right there, and that way I don't have to check for that in my code, right? It's already checked for. And so show profile is on get, and so parsing a template, and then data store new key profile, and the key is based upon the user's email. And then data store get, put it all into instance of the struct profile. And then execute the template and pass in the profile, so they'll be able to show me the user information. And then here's the HTML. So this is templates, right? Parsing files, templates, go HTML. And my code is actually right here a little bit off. Maybe I should look at it in here, because this template got defined as edit form. So if I was to actually use this template here, I'd need to change parse files to edit form.
No.
Oh, right here,
Yeah.
execute, right
Yeah.
there, edit form. So I'm parsing the file, and now I'm choosing that one to run. That's right. Take back what I said. It's not off. Edit form. And, right, we pass in, and then the fields we're accessing are right here. First name, last name, age, email. So we're adding that. And you could also just define your template like that. So there's that way, right? So I didn't put in, there's no defined edit form like up here, right? In which case it just takes on the name of the file.
Do you do like that? You can't have more than one template in the same Go HTML file, though.
Right, one template per HTML file. That's pretty much the way I think I want to think about it, though. Like, why would you do many in one file? I think that's just my old school. Each file is
I would do
page.
many in one file if I've got like a range-based loop or something that needs to go to some sub template for its internal value. Alternately, if there's something that needs to be across all pages, like if I was thinking a forum, the header bar or something.
The header and the footer, put them in the same file.
Yeah.
And then just define them.
Yeah.
Cool.
Yeah, typically, though, you will use a separate file for each HTML page, though.
Yeah, that's the way I like to think about it. So this is to update the profile, get the key, and then doing ASCII to int, right, with age, because age is coming back from the form as a string, but we need it to be an int for our struct. And then populate a struct of type profile. That's kind of interesting. Right there. Let's actually look at this this code. Let's see that. Filter. This the right file?
No.
No. Query filter. Users data store exercise. That looks promising.
Yeah.
So I have a profile up here. Defines the struct. And then we were just looking at update profile. I don't know why that's looking different to me, because I probably didn't do this, right? I didn't do the var one. Var profile, and then profile is equal. I think this is the way I was doing it before. All right, and then profile is equal to, can you do that?
I think you still need the words. I think you still need to label profile before the curly braces.
Profile before the, oh, so that'd be the same thing.
Yeah.
All right, I like that way better. So populate the struct, pass it into the data store to put it, and that's that. A little bit of information about Julian Schmidt's router. So here you have get index, right, and then get hello, and then colon name, the variable deal. And you can see here, hello will access PS by name. So these are my parameters, my params. And by name is passing in name for that one, right there. So it'll give me whatever is in that position. And then I could use that right here. So that's just going to the /, which runs index, which prints out welcome, and / hello Todd, which, whoa, can't click on code, puts Todd right, Todd's right there, so, access that and then use it right here. So those are pretty much like the two big features of Julian Schmidt's router, being able to do the HTTP verbs right here, and then have variables in your path names. And that saves us having to do that fields split string or string split fields, and then also having to check the method.
I don't think we've ever demonstrated how to use Julian Schmidt's routing with App Engine, since you can't use listen and serve and pass it in.
Yeah, I don't think we have. How would you do that?
Use the normal default mux and just define a route to nothing with just plain handle and have it go to Julian Schmidt's routing from there.
So drop my app YAML in, get rid of main, make it init, and I need to get rid of listen and serve. So you're suggesting, walk me through this, Daniel.
Yeah. So I'm suggesting after you've made the router, instead of this big listen and serve thing, you can use use just HTTP.handle. And for just a plain / everything, and have it go to the router from there. Because App Engine always uses the default serve mux, so you just tell the default serve mux that everything goes to this other handler, which is the actual Julian Schmidt router.
And does that need to be the top?
I don't
Order
think it
matter.
matters. It just has to be made after router's made. I don't think it matters order-wise up past that.
Which one doesn't matter? There's one where it matters. That's in your app YAML definition, where if you set your ads in there, the order matters.
Yeah.
Because that looks kind of redundant, like it'd be confused, like which one, right?
Yeah.
But it somehow knows that when it gets this, I'm using router.
So yeah, it's the App Engine is using the default serve mux. The default serve mux is what's registered with the HTTP handle. So it's an HTTP stuff, and it says, oh, I've got one thing registered, which is /, which in serve mux is everything.
Oh, because before we had look at me going up and down all that. We had HTTP listen and serve.
Yeah, with HTTP listen and serve, you could tell it's something besides the default serve mux.
Okay, and it could have been just been like that in this default serve mux.
Yes.
Right.
So yeah, it's always default serve mux in the App Engine.
Nice. Oh, I don't want that. I don't want this. Let's run it. Boop, boop.
Oh, 4.
Oh, 4. My eyes aren't what they used to be.
Go app serve. Let's see what it is.
There are too many files. It looks good. That doesn't look good. Imported, not used. We could be like car talk for Go programming. But then we have to like get old computers and create a program and have them crash into each other. What's that England show where they have the cars? They do that. Oklahoma City 80. Welcome. And I think it's hello, right? Yeah. Sweet. Very nice, man.
So yeah, if you want to use Julian Schmidt with App Engine, that's how you do it.
Or rename this with App Engine. Cool. All right, I think that's a good stopping point.